A lampshade is made in the form of a lateral surface of the frustum of a right circular cone. The height of the frustum is 3√3 inches, its top diameter is 6, and bottom is 12. A bug is at the bottom of the lampshade, and there's a glob of honey on the top edge of the lampshade at the spot farthest from the bug. The bug wants to crawl to the honey, but it must stay on the surface of the lampshade. What is the length in inches of the shortest path to the honey? Let's first draw a cone, and let's label as much as we can to get an idea. So let's call this top O, and then the bug is going to be here. Oh, sorry, the honey is going to be there, and the bug will be here. So B for bug, H for honey. And then I'm going to draw a line top to bottom right there. Okay, so let's see what we can do. This distance we don't know. This distance we do know is 3√3. That distance, the diameter is 3, so that means that radius, it would be 3. And that diameter is 12, so that radius would be 6. So using similar triangles, it would be x over 3 is the same as x plus 3√3 over 6. Correct? So 6x would be 3x plus 9√3. And therefore 3x would be 9√3. And therefore x looks to me like 3√3. Okay. And therefore this distance OH would be x squared plus 3 squared if you're using that Pythagorean relationship. So that's 9 times 3 is 27 plus 9 is 36, so OH would be 6. Okay, so OH is 6. And then in a very similar way, we can calculate OB. That's going to be the full top to bottom, which is 3√3 plus 3√3, so 6√3, so 6√3 squared, and then plus 6 squared. So that's what 36 times 3, 108 plus 36 is 144. That's OB squared, by the way, and then OB would be 12. Okay, so I just wanted to do that. I wanted to get some idea of what dimensions we're working with. Okay, so now we have to move on to the nitty-gritty here. When we open this up, and you guys hopefully, if you're practicing, just take out a piece of paper and draw a cone and open it up, and you'll notice it'll look something like this. And that cross-section right there is what we have to cut out to make the frustum. I've never, believe it or not, I don't think I've ever heard of that term, frustum. But I know what they're talking about. It's just basically this part would be remaining. This part right here. That part would be remaining. And that would basically be the lampshade. Okay, so again, we're going to have the O, and then these sides are 12, right? Is that right? Let me make sure I do that correctly. I think so. And then the angle, So, well, this from here to here, that is basically the entire circumference of that circle. So circumference is equal to pi d, right? So circumference would be pi times diameter, so it would be 12 pi. Since the diameter was, so that's 12 pi, that entire sort of arc. And I'm very interested in this angle here. So the angle over 360 degrees would be the equivalent of that arc over the total. Like if this thing went all the way around and made a full circle. And so that's going to be pi times diameter, which would be pi 2r. But the r in this case is 12, the distance from there to there. So that's going to be theta over 360 would be 12 pi over 2 times 12, which is 24 pi. So that means theta over 360 is a half. So that means that theta is 180. All right. Okay, if theta is 180, that's very interesting. So now we have to get down to our comparison between the honey and the bug. Now, what's interesting is when you're here, I labeled it properly, but when you open it up, the temptation is to label it again like that, but that would be wrong. Why? Because when you open it up, it doesn't look like that. When you open it up, the honey would be here. It would not be here. Why? Because they are farthest from each other, the farthest. See, in this diagram, it's labeled properly, but when you open it up, it's going to be there. If it was here, then when you closed it back, they would not be the farthest. The honey and the bug would be there. You see what I'm saying? They would be sort of on the same side, I guess. Okay, so now we have to finally figure this out. And conceptually, this is actually difficult, in my opinion. So let me just try my best to explain this. So here's the diagram. Okay, so we've got, where is the bug? The bug is here, right? And the honey is here. Now, common sense will tell you that the shortest path between any 2 points would be a straight line. Okay, so let's draw a straight line. And there we go. But here's the problem. The problem is that the bug must stay on the surface of the lampshade, and the surface of the lampshade is really like there in that region. And you notice that green line goes into this region here, and that's not allowed. So then what do? Well, obviously, that is the incorrect way. So the correct way, let's try it again. And this is certainly not drawn to scale, but I have to draw it in this way in order to illustrate how to do this question. Otherwise, I don't think I'd be able to explain it properly. So the way to do it, actually, is first you have to draw a line that's tangent to that inner circle. So let me see if I can do that carefully. Yeah, like that. See? And then that is the closest you can get. So that is sort of the tangent point right there. And from here to here, that is the closest that we can get. And then from that tangent point, then you have to follow the curve in order to get to H. So that is the only way that this question can work. Okay, so now that we have that established, we have to now figure out, remember this was O, and let's just draw a straight line from there to there, and a straight line from there to there. Now the good news is, since that line was tangent, that is 90 degrees. That's a property of a tangent line to a circle. And therefore, since we've got this triangle, let's just call this C, that tangent point, and I'll draw that triangle here, and just to avoid making that diagram messy. So we got C here, we got O here, we got B here for the bug. Okay, now let's see, do I know any dimensions? O to B is 12 from here, so I know that. And O to C is the distance O to C is sort of the distance from O to H, which would be the distance from here to here, which is 6. Yeah. Okay. And therefore CB, using Pythagoras, would be 12 squared minus 6 squared, which is 144 minus 36, which is 108. And therefore CB would be the root of that. And I believe that's 6 root 3. Okay, so 6 root 3 is part of our answer. That's very good. Now, we still need to figure out that arc arc that's going from C to H. So how do I do that? In order to do that, I'm going to need this angle in here. So whatever, let's just call it alpha since I already have a theta. How do I figure out that arc? That angle, I should say. Well, this triangle is a 30, 60, 90 triangle because the ratios of the sides are 2, 1, and root 3. And you guys know that. I mean, that's very common. So that means this is 30 and that's 60. If that is the case, then that means that this is 60 degrees. So since this thing was 90, then alpha is 30. Okay, great. So I got it. Okay, so our final step is to figure out that arc. Well, that's going to be that 30 degrees over the full 360 multiplied by the full circumference would be pi times diameter, or pi 2r. So that looks like 1 over 12. What's r? R is from here to here, right? So that's 6. So that's going to be 12. So that this reduces to pi. Okay, so the full is BC plus CH. Well, BC is 6 root 3, or CB, whatever, and then plus pi. So there we go. That is the answer. 6 root 3 plus pi is answer choice E. A real valued function f has the property that for all real numbers a and b, f at a and b plus f at a minus b is equal to 2 f at a times f at b, which of the following cannot be the value of f at 1. All right. Well, let a equal b, and let's see what we can do here. So that equation then becomes f at 2a plus f at 0 is equal to 2 f at a times f at a. Correct? So if a is 0, this would basically become f at 0 plus f at 0 is equal to 2 times f at 0, I guess all squared. So this is 2f at 0 is equal to 2f at 0 all squared. And therefore, if we solve this, f at 0 would be either 0 or 1. Correct? Yeah. Okay. So, therefore, if we look at f at 2a, and that's from this guy right here, that's going to be 2f at a all squared minus f at 0. Correct? And they're eventually wanting us to calculate f at 1. Okay, so I think it'll be helpful if we can eliminate some of these with some boundaries. So let's see, how do I do that? Let's see if I can minimize this guy. Minimize it. So 2 is 2, can't change that, but that, since that's being squared, to minimize this, I'd have to minimize that and maximize this guy. Okay, so to minimize this expression, basically. Well, the minimum value of f at a squared is 0. The reason is because f at a squared has got to be at least a positive number or 0, since it's a square of something. You can't get a negative if you square something. And the maximum value of f at 0 from here is 1. There's only two values, 0, 1, and the maximum of those two is 1. So that is that. So that looks like to me minus 1. So minus 1 is the minimum value. So that means that f at 2a, the minimum value is minus 1. So the f at 2a has got to be greater than or equal to minus 1. Does that make sense? Yeah. It's got to be greater than or equal to minus 1. Okay, so now finally, if we let a equal to a half, we will get f at 2 times a half, which is f at 1. So f at 1 has to be greater than or equal to negative 1. So all of these are greater than or equal to negative 1, except this guy. So that is how you eliminate it. That is the one that it cannot be. So E is the answer. A irregular pentagon with area 1 plus root 5 is printed on a paper and cut out. All 5 vertices are folded to the center of the pentagon, creating a smaller pentagon. What is the area of the new pentagon? Well, you have about 2 minutes to solve this question. So you want to use a ruler to get the fastest possible outcome, because otherwise the solution is very long. So rulers are allowed on the AMC exam. So what you do is the shape. A regular pentagon is very easy to draw, and then concentrate on this sentence. All vertices are folded to the center. So this is the center, obviously, and when you fold it, the vertices should match. So that means halfway in between is where that fold is made. And therefore, once you make those folds, you will get the inner, smaller pentagon. And that is the area that you're trying to get. Okay, so this is what I did. First, I looked at a pentagon and I said, well, how do I figure out the area of a pentagon? There's a formula, but the formula is quite complicated, actually. I don't like the formula. So what I did was I realized if I draw a center, it's really just 5 of the same triangles. So 5 times 1/2 base times height. So this is the base right there, and the height would be right there. So if I can figure out the base and the height with my ruler, I should be in business. So the first thing I did was I measured on the big guy the base and the height. So from here to here, I measured the base, and it was about 2.2 in my ruler. And then I measured the height, meaning the height that would go from one of the triangles, so it would be from there to there. You get me? Like, just very similar to that, trying to figure out the height of one of those triangles. And that was about 1.6. So that means that would be 5 times 1/2 times 2.2 times 1.6, and that's about 8.8. Okay, great. Now I do the same thing for the internal, smaller pentagon. Let me just draw that line there. And then this time the base is this guy and the height is this guy. So that base I measured and it was 1.4, and the height I measured and it was 1. So this is about 3.5. Okay, great. But that is just this particular diagram. We are actually told that it's 1 plus root 5. So then we have to make a ratio. So that means root 5 plus 1, which is the actual area of the big pentagon, over, say, the area of our smaller pentagon, which I don't know, which is what we're trying to figure out, would be which should be the same ratio as what I just figured out with my ruler, which is 8.8 for the big guy and 3.5 for the small guy. So that means A would be approximately, let me see if I did this correctly here. 8.8A would be 3.5. Oh, I gotta convert this root 5 plus 1 into a decimal. Root 5 is what, about 2 point something? Yeah, 2.2. So 3.2 approximately 3.24, I think. And then therefore A would be 3.5 times 3.24 all over 8.8. And that is approximately 1.2. And of these answer choices, the one closest to 1.2 is this guy. So as you can see, in a relatively decent way, you can get the answer to the number 25 problem using just a ruler.